Okay, folks. So for today's lesson, our goals are going to be able to create and interpret a velocity versus time plot for an object that is accelerating. For our agenda today, we're going to take notes on how to make and interpret velocity versus time plot for an accelerating object. And then you're going to do some practice problems where you make and interpret some velocity versus time plots for accelerating objects. Okay, so first let's just review a little bit. Position versus time plots for objects moving with constant velocity. So objects whose velocity isn't changing are linear. And so we can see that over on the right here. We've got a linear graph. Um, the line goes up, with a steady slope. It's not curved at all. It's just a straight line. And the velocity versus time plots for objects moving with constant velocity are horizontal. And so I want you to go ahead and draw a horizontal line in here. Remember that the value of this horizontal line is just the slope of the position versus time plot above. So because this line has a slope of -1/2, we're just drawing a positive 1/2. We're just drawing a horizontal line at positive 1/2. Okay, but in this unit, we're working with objects that don't have constant velocities, right? Objects whose velocities are changing. And so we're going to talk about how the position versus time and velocity versus time graphs look different. The position versus time plots for objects moving with changing velocity are quadratic. And that's what we see on the right here is that we have a plot. We can see that the line is increasing quadratically. And that's because this object is accelerating. It has a changing velocity. And so the velocity versus time plots for objects moving with changing velocity are linear. And so we can see that here, and you can go ahead and draw this line in, but we can see that the velocity versus time plot for this graph above is linear, meaning that the velocity is changing at a constant rate. So the velocity versus time graph is just a straight line with a slope. Okay, and so then let's keep going. General equation for a quadratic, again, this should be reviewed, but it's y equals ax squared plus bx plus c. And the equation for a position versus time plot of an accelerating object, that's this formula, x equals 1/2 at squared plus vit plus xi. So let's just kind of review how these two equations are related. So y is our equal to x, that would be our dependent variable. In this case, x is position. X equals t, that would be our independent variable. In this case, t is time. A equals 1/2 a, or 1/2 acceleration. And so this a equals 1/2 a. B equals vi, or starting velocity. And c equals xi, or initial velocity. Okay, so then we're just going to rewrite that equation from the last slide. X equals 1/2 at squared plus vit plus xi. And the equation for a velocity versus time plot of an accelerating object is v equals at plus vi. So again, this a is the same as this a, the acceleration. This t is the same as this t, the time. This vi is the same as this vi, the starting velocity. And so we can see that, that in general, this formula has the form y equals mx plus b, so it's going to be a linear equation. The acceleration is our slope. The initial velocity is our y-intercept. And this v stands for velocity. So basically the v is going to tell us how fast the object is going at any given time. Okay, so let's go through how to use that, how to use this formula to write the, to create the velocity versus time plot for an accelerating object. So first of all, I need to give you the position versus time plot, and I need to give you the formula for that plot for you to be able to make the velocity versus time plot. So here I've given you that plot from before, and I've given you the equation for that plot, the best fit information. And so then what you're going to do is use that to write the equation for the velocity of the versus time plot, and then you're going to use that equation to make the velocity versus time plot. So we're going to start with that same formula from the last slide, v equals at plus vi. And so we can see this is what that formula works out to be. Now, where did we get that from? Well, 1 meter per second, that came from 0.5 meters per second. We're just multiplying that by 2 because this is 1/2 a, but we're looking for a. So in order to get a, we need to take this value and multiply by 2. And then really vi is just 0 because that was 0 in the previous equation, right? Vi is 0 here. It's going to remain 0 meters per second here. Okay, and then we can use this information now to make our plot. So we're going to start with the initial velocity, that's 0 meters per second. Oh, sorry, I should say again, this follows the format y equals mx plus b. So 1 meter per second is going to be our slope, and 0 meters per second is going to be our y-intercept. So we're going to start with the 0 meters per second, and that's going to go on our y-axis. And then when we make our plot, because the slope is 1, it's going to go over 1 and then up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1. And so it's going to look kind of like this. And you can see that this line has a slope of 1, right? For every 1 unit over, it moves up 1. And so that's our velocity versus time plot. Now, on the next slide, we're going to use these plots to answer some questions. And so the first question that I ask is, where will the object be located after 2 seconds? So because we're looking for a location here, we're going to be using the position versus time plot. So we're going to find 2 seconds on that x-axis, and then we'll follow it up to the graph, and then we'll follow it over to the y-axis. Gets us at 4 meters. So where will the object be located after 2 seconds? It'll be located at 4 meters. How fast will the object be traveling after 2 seconds? So again, we're gonna find 2 seconds on this axis. We're gonna follow it up to the graph, and then we'll follow it over to the velocity. It looks like it'll be traveling at 2 meters per second. When will the object reach a position of 9 meters? And so I'm going to start with 9 meters on this axis, follow it over to the graph, follow it down to the time. Looks like 3 seconds. When will the object be traveling at a velocity of 3.5 meters per second? So I'm going to go to my velocity versus time plot. I'm going to start at 3.5, follow that over to the graph, and then I'll follow that down to the axis. It's in between 3 and 4. We're just going to call it 3.5. So 3.5 meters per second. Okay, so hopefully this example made sense. I've got a couple practice problems here. Give those a try, and then we'll go over those as a class when we meet next.